we have to show that angle 1 is congruent to angle 2. On this diagram, we have these red arrows. It means that these two segments are parallel. Let me write this, that AG is parallel to BE. And we have this given. So if we extend these two parallel lines, we see that CG or GC, doesn't matter which way we put, is our transversal, and by alternate interior angles theorem, we have that these two lines are parallel. This is our transversal. Then alternate interior angles are congruent. So we can write that angle, let's put that here is angle. Here we have 2, so let's put that here is 3. Angle 3 is congruent to angle 1. We can write. We had that angle 3 is congruent to angle 1. Let me remind you, alternate interior angles are angles which are between these two parallel lines and opposite side of our transversal. So these two angles are congruent. What else? Now we have also given that DE is parallel to CG because we have these double arrows. So we can extend again these two parallel lines. Let me write this, that DE segment is parallel to CG. This is given. So again, by alternate interior angles theorem, now if we treat our BE as a transversal which cut these two parallel lines, we have that alternate interior angles are congruent. So now angle 3 is congruent to angle 2. One more time, if two parallel lines are cut by transversal, then the pairs of alternate interior angles are congruent. Let me remind you, alternate interior angles are angles which are between these two lines and opposite sides of our transversal. So 3 and 2 are alternate interior angles. And by alternate interior angles theorem, these two angles are congruent. So we have that angle 3 is congruent to angle 1 and angle 3 is congruent to angle 2. So now by transitive property, we have that angle 1 is congruent to angle 2. This is my solution.